What we're going to do now, touch on some of the topics. We'll talk about grain sizing, coating thickness, multi-modal microscopy, and how this can benefit you if you're using or requiring multiple methods for analysis. So say, for example, you need to check the quality of the incoming material for your goods and also the finished product. You want to ensure that the integrity of the material is there, whether it be from a coating thickness standpoint or a grain structure standpoint. So how do we do this? Well, first of all, we actually need to expose the structure of the actual material. So in order to do this, we actually cut the material or the component, we mount it in a resin block, and then we polish the surface, exposing the structure underneath. We then put this resin block on the microscope, and we can then launch the ZenCore software, and then we should see a really nice, sharp, clear image of the structure underneath. Now, whether that be the grain structure or the coating thickness. Now, once we are running with the software, as I mentioned, we have this nice grain structure image. The software can then analyze the grain material and look at the grain boundaries and then do the automatic segmentation. Now, the segmentation and the detection of the grain boundaries can also be interactive as well as fully automated. Now, at the end of that process, we end up with a grain size distribution chart, and this can be done on multiple images, and then we can give you a nice report, which gives you the image number and the grain size number to the standards for each of those images. And in the report, we can give you a mean grain size number as well as standard deviation. So we can actually do this grains analysis to international standards, which could include DIN EN ISO 643-2020, ASTM E11213, ASTM E138297, and GB/T 6394-2017 plate 1 to 5. Now, when it comes to coating thickness, we can do exactly the same process. So we've exposed the coating thickness with the preparation method. The software will then look at the layer thickness and automatically detect those layer thickness boundaries. The software will then automatically place chords for the layer thickness measurement. And again, this can be done fully automated or interactive. Now, once the chords are in place, the software will then give you the measurement, which will give you the mean layer, the minimum layer, and the maximum layer. This can also go into a nice report, including the images that you've required to do the analysis. And again, it can be done on multiple images. We can give you a mean layer thickness across the board, minimum, maximum, and the standard deviation. And again, this coating thickness measurement is done to international standards. So DIN EN ISO 1463-2004, ASTM B 487-2007. Now let's talk a little bit about the multimodal microscopy. Now, what if you need to do some in-depth analysis once you've looked at your component or your sample with an optical microscope? Well, normally it would take quite a long time to relocate particular fields of view or particular regions of interest on a scanning electron microscope because the magnifications are so high and the resolution is so high. What we can do here is make it a lot easier for you. So once you've acquired your image on your optical microscope, you can then define regions of interest or particles or fibers or fractures that you want to investigate a little bit further. Now you can take the sample holder off the optical microscope and place it in the scanning electron microscope, where you can then automatically relocate those particular regions of interest. So you can then look at the light microscope image, the EBSD image, and also for the elemental analysis. So here you can look at the chemical composition of the particles or defects or material that you want. And again, have a nice report at the end of it, giving you the material distribution. So thank you very much for spending your time and listening and watching today.